Hello, this is the video math homework number 2. Today we are going to be doing graphing piecewise functions and also compositions of functions. Alright, so first we're given a piecewise function. We are given 3 if x is less than 0. And square root of x if x is greater than or equal to 0. So first, we want to graph each piece individually on the graph. Then when we do that, we want to restrict each piece to the domain specified in the function, as in right here. And then we're going to combine them all into one graph. And then we need to indicate whether the endpoints are open or closed. So first, we're given 3 if x is less than 0. So what I did, we have y equals 3. So we go and we look, we go 1, 2, 3. So that's where our line is at. It's a constant straight horizontal line. So I just drew my line in the purple because it's going, that's at 3. And then we need to find it when x is, we need to restrict it, like that says. So everything is possible when x is less than 0. So everything to the left side of 0 is true. So that's going to be our dark purple part of the graph right here. And also we have an open circle right here because we have a less than sign. If it was less than or equal to, that equal to indicates that it's a closed circle, but obviously that's not the case here. Then same thing for square root of x. We know that y equals square root of x, and I know that square root of x starts at the origin and it goes like that. And so I drew that in the light purple, going like that. And then we have to restrict it. So x is greater than or equal to 0. So we find 0. And it's a closed dot because it is equal to. And it's true for everything on the left side that's greater than 0. So this whole line is going to be true. Now we just have to put it all together. This is the final graph. Obviously you see we have our open circle at 3 going that way, and then our closed circle going that way. So that is our final answer that I got. Same exact thing for problem number 2. We're given x squared if x is less than 0. And then we're also given 1 minus x if x is greater than 0. Let's see. So first, I started by graphing each piece. So we're just going to start by graphing the left side of our piecewise function, which is y equals x squared, which I know that from what we've learned in class, it's a parabola. So it's going to look like that, just like I just drew up here. Same thing for this one. Let's see. We are given 1 minus x, 1 minus x, which we can also rewrite as negative x plus 1, which is easier to tell from that. So we know negative x plus 1. This acts as the y-intercept. So we started at 1 right here. And then this is our slope, which is a negative slope. So we know this is a positive slope. So we know the slope is 1 or negative 1. So the line is going to look like that. Then we have to restrict it. The part that's specified in the function. So we're going to do the right side now. For the first one, x is less than 0. So we're going to restrict everything but anything less than 0. So that means anything on the left side is true. So you can see that's how I highlighted it by the dark purple line. And obviously it is an open circle because of the inequality presented. Let me make that better. All right, so now we just put it together. Here is the final advice. As you can see, that's our final answer. We just combined it. We combined the restricted pieces to create the full graph of the piecewise function. And again, these are both open circles. We can tell that by the inequality because they're not equal to the number. So it's not true all the time. So these are both open circles. All right, same exact thing for number 3. We're going to look at our inputs. So x cubed is what we're given for the first one. I know that when we have x cubed, that the graph is going to look somewhat like that. Not the best artist, but whatever. So obviously that's how I drew it, because you can see from the purple line. Same thing for negative 2. Y is going to equal negative 2. It's a straight, constant, horizontal line. Or a constant number. And then same thing for this. I know that when we're given square root of x, y equals square root of x, we start at the origin, and then it goes out like that. Super fun. Yay. So now we need to restrict the attention to the given domain intervals for each piece. So right here, we have to restrict when x is less than negative 1. So it's true when anything is less than negative 1. So we find negative 1 on the graph, which is right here. And we go like that. So it's true when anything is like that. And it's an open dot because, as you can see from our inequality. So for this one, It's a little more complicated, but it's not that hard. So our first restriction is -1. So we find -1, which is right here. Then we have to go down because our line is right here, obviously. And our inequality is less than or equal to, and that equal to indicates it's a closed dot. So obviously we have a closed dot here. And it goes from -1 to 4. So that's where we have to stop that 4. It's between -1 and 4. Anything in between. And it's going to be, 4 is going to be an open dot, as you can see from the inequality. Same thing for this. It's a closed dot. You see our lines going like this, but we have to restrict it, so it's only true when x is greater than 4, greater than or equal to 4. So we find 4, which is right here, and so that's what we get right there. So this is what the final graph is going to look like. Yep. As you can see, we put all of the 3 pieces together. Yay! All right. Problem number 4, compositions of functions. Like f of g of x and g of f of x. Then we have to simplify. So first, I have to show the substitution step to form f of g of x. So f of g of x. So we want to find that. How can we do it? Well, we can start by plugging in g of x into f of x. So let's dive into how we can do that, because I know that sounds a little complicated. So we're wanting to find the whole thing, f of g of x. So we have f of x for the first one, which is f of x equals x squared plus 1. Okay? So the easiest way that I think to do this is, so we write out, so we have x squared plus 1. To find f of g of x, we have to plug g of x, which is x squared plus 2. We have to plug that into the x for f of x, okay? So we're going to go from this, and we're going to plug in this for this. So x plus 2 squared, or square root squared plus 1, which is what we're doing right there. And obviously, as you can see, the squared and the square root cancel out. So then we're left with x plus 2 plus 1. And we can combine like terms. 2 plus 1 is 3, so we're given x plus 3, which is what f of g of x equals. We have to, so that's the simplified and the result of f of g of x. Now we have to mention any restrictions on the domain that come from square roots, absolute values, or other limitations. So here, we're wanting to look at the restrictions or the domain on the domain. So we have g of x equals x squared plus 2. And we can rewrite this as x plus 2 is greater than or equal to 0, because we know that anything in square roots have to be greater than or equal to 0 to be true. So what I did was I got this, then I set it, just tried to isolate the x. So I subtracted 2 on both sides, which gave me x is greater than or equal to -2. And so obviously our domain we can find from there, which is x is greater than or equal to -2, which if we put it on the line, this always helps me out. We know that this is a closed circle because of that. And x is going to be greater than any of that. So it stops from -2, and then you see right here as we went to infinity. So that's the domain for the first one. Whereas we want to also find g of f of x. So we plugged in this. So that's what we start with. And you see how we have x here? This is acting as our x. So we're going to plug this into that, if that makes sense. Excuse me. Okay. So we plug that in, and we get x squared plus 3 under the square root, which is our final answer. We can't really simplify it from there. For the domain, restrictions on the domain, that's what we did. Obviously, when we have a square root, we have to set it greater than or equal to 0. We know that x squared is greater than or equal to 0 is all real numbers. It's true. And so we're given x squared plus 3 greater than or equal to 3. It's true. So our domain ends up being negative infinity to positive infinity. Same exact thing for B. I got for f of g of x, it equals square root x squared plus 5. We're given this. This acts as our x value, so we're plugging in this into x right here. So we get square root x squared plus 3 plus 2. Combine like terms, we get that. And then for our domain, again, anything under the square root, set it greater than or equal to 0. That's true. So it's all real numbers, negative infinity to infinity. Same thing for g of x. Just plug that in. The square root and the square cancel out. Our final answer is x plus 5. For this, we have to go back to the original problem instead of that, and which is x plus 2, which gives us x plus 2 is greater than or equal to 0. Subtract on both sides, we get x is greater than or equal to -2. If we look on it on the scale again, -2. X is greater than or equal to 0, so it's from here to there. So we have -2, infinity. Woohoo! Okay, last one. Finally, we're dealing with absolute value, which can be tricky. We're looking for f of g of x here. So, we start with x, absolute value of x, and we want to plug in g of x for x. And this is x, okay? So the easiest way to do that is obviously absolute value, 5x plus 1, because we plug that in. And we can't really simplify it from there. So this is our final answer. And we know that it is all real numbers, negative infinity to positive infinity, because of absolute value. And then same thing for g f of x. Plug that in, and we get that, which equals that. This is a plus, by the way. So we have g of f of x equals 5 absolute value x plus 1. We can't really simplify that, but we do know that absolute value of x is all real numbers. And so we know that 5 of x, absolute value of x plus 1, is also all real numbers, which gives us negative infinity to positive infinity. And yeah, and that is it. Thank you.